everyone, how are you? I hope you all are super amazing. Welcome to Swiflearn, India's most sincere learning destination for classes 1 to 10. Today we are back with another new topic which is on histograms and ogives. Before we dive into a topic, I want to give you a brief description about Swiflearn. At Swiflearn, we provide 100% live and interactive classes at the comfort of your home and according to your convenient timings. Here at a batch, we have a maximum of 6 students, so never more than 6 students, because we believe in imparting equal attention to each and every child. If you want, you can also go for one-to-one tuitions as well. At Swiflearn, we have a dedicated academic mentor team who is going to track your progress and guide you throughout your journey. We cover the syllabus as per the school exam schedule, and we also handle custom requests. Let us look at the key features of Swiflearn. Here, monthly, we are going to provide you with the detailed progress reports, and we are going to share it with your parents as well. Here you can take unlimited practice tests, because we all know that practice makes a man perfect. On every Sunday, we conduct a scholarship test, which is the SATS test, Swiflearn Academic Test Series. And not only we cover objective tests, but also subjective tests as well for school exams. Sounds amazing, right? So what are you waiting for? Make sure to go to the Swiflearn website and book a free trial class today, right after this session. Also, if you are new to this channel, make sure to subscribe the channel and hit on the bell icon, because here we share really knowledgeable videos from time to time on various other subjects, and all these videos are going to help you. So press the bell icon so that you never miss any update from us. Okay, now let's look at our topic, that is graphical representation. Let's see, what is it? So today we are going to talk about histogram, plotting the histogram for continuous grouped data, plotting the histogram for discontinuous grouped data, and plotting the histogram when class marks are given. So we are going to cover very important topics today. Now see, among the crores of people, how the government tracked the COVID-19 disease. Have you ever thought about it? So many people, right? The government were tracking that who all were badly affected by COVID, right? And who all recovered from COVID. So many data. So how did government do it? By converting the data into tables and graphs. Okay, so whenever you convert the data into a tabular form or a graphical form, then it becomes really easy to study them. In graphs, histogram is one of the most essential tools for studying the public health. Now, let's recall representation of data. Usually, comparisons among the individual items are best shown by means of graphs, right? For example, if we take the number of students and let's just suppose that how many marks each student has got. Okay, so like less than 80, more than 80, more than 90, less than 90. So if I just keep on telling you, or if I just keep on writing that this student got this much marks, this student got that much marks, then it is not going to be, very easy to study. But the moment we turn it into a graph, then it becomes very easy to study the graph. Okay, like in the chart form, the representation then becomes easier to understand than the actual data. Have you ever noticed that even while studying also, whenever we put the data into a chart format, then it becomes really easy to memorize, right? It happens a lot. We will study the graphical representation of data in the following 2 forms of graph. Okay, so we are mainly going to deal with 2 forms of graph. Number 1 is histogram. Number 2 is ogive. All right, I think this is a new term for you. You can pronounce it as ogive or ogive. So different people pronounce it in different manner, and it is also called as the cumulative frequency curve. What is the meaning of cumulative? Cumulative means when something increases steadily, when something increases at a successive rate. Okay, but we will look into ogive in details later on. Today we are going to study mainly about histogram. What is a histogram? It is a plot that lets us to discover and show the underlying frequency distribution or shape of a set of continuous data. Okay, So what do you mean by continuous data over here? Let's look at the terms. Okay, continuous data means like when I'm talking about the range, for example 10 to 20, 20 to 30, 30 to 40, right? So here you can see जहां पे खत्म हो रहा है वहीं से ही शुरू हो रहा है ना? Wherever it is ending, from that point only it is starting. Therefore this is continuous. But if I take the range as 10 to 21, okay, then suppose 22 to 41, maybe like this, then it is ending at 21 but it is starting at 22. Okay, so this is not continuous. All right, okay. Let's see. A histogram is a 2D graphical representation of continuous frequency distribution. 2D means what? Two-dimensional, right? So we will consider the x-axis once, and then we are also going to consider the y-axis. So two dimensions, x-axis and y-axis. This is why we are calling it as 2D graphical representation of continuous. Continuous, I've already explained to you, frequency distribution, right? So once we deal with an example, you will understand it better. But generally we know here on the y-axis we plot the frequencies, and on the x-axis generally we plot the class intervals. So what is the meaning of all these terms? Let's see, right? Okay, let's see. In this case, rectangles are drawn with bases proportional to class intervals and heights proportional to frequencies of respective classes. So just now I showed it to you, right? That here on the x-axis, here you have the x-axis, here you have the y-axis, and we are taking the bases proportional to class intervals. Means here we are dealing with the class intervals. That means the ranges. And heights proportional to frequencies. Heights means what? Along the y-axis we are plotting the frequencies. Okay, simple, very simple, no need to worry. Now let's look at some terms: class interval and class limits. The presentation of data expressed into groups, these groups are called as classes or the class interval, right? For example, if we talk about ages, so all the ages between 10 to 20 years, okay, then this is what is happening. We are presenting the data in a group form. So this group will be called as your class interval, and each class interval is bounded by two figures called as the class limit. So when I'm telling you 10 to 20, this 10 will be called as your lower class limit, okay, lower class limit, and this 20 will be called as your upper class limit. Okay, so these two are the class limits. So what is the lower class limit and what is the upper class limit? These two are required to express a class interval or the range. Easy. Okay, now let's look at the types of frequency distribution. How we are distributing the frequency. What do you mean by frequency? Okay, for example, if I tell you that the frequency of 10 to 20 years, okay, this is the class interval. I am telling you that the frequency is say 3. That means the numbers between, all the numbers that are present between 10 to 20. All right. Generally in a class interval, we think of all the numbers, like if it is 10 to 20, then we are going to talk about 10 to 19. Okay, we are going to exclude the 20 years. We are going to talk about 10 years, 11 years, 12 years, like that up to 19 years. So these have occurred exactly 3 times. All right, so this will be your frequency. That means how many times this is occurring. Okay, how many times this is occurring, that will be called as your frequency. Now, in the types of frequency distribution, we have inclusive type and the exclusive type. So what are these types? Let's see. Inclusive method. Under this method, the classes are formed in such a manner that the upper limit of a class interval does not repeat itself as the lower limit of the next class interval. Very easy. Look at the example. 0 to 5 is a class interval. Next class interval is from 6 to 10. Okay, so upper limit is 5, and this 5 is not repeating itself in the next class interval. Okay, see, upper limit of a class interval does not repeat itself. Okay, so it is from 0 to 5 and then 6 to 10. So this is the upper limit and this is not repeating itself in the lower limit of the next class interval. This will be called as your inclusive method of frequency distribution. See, 6 to 10, 11 to 15. Again, 10 is not repeating itself. Okay, this will be called as the inclusive method. Very easy. Next, come to exclusive method. This method is used for those series in which the upper limit of one class becomes the lower limit of the next class interval. That means in the first class interval we have 0 to 5. In the next class interval we have 5 to 10. Okay, so this is the upper limit of the first class interval and this is only acting as the lower limit of the second class interval. So this 5 is repeating itself. So this will be called as the exclusive method. Again 5 to 10 and then again from 10 to 20. Again from 20 to 30. So this is like your continuous frequency distribution, right? I told you 10 to 20, 20 to 30. This is continuous. Because if it is in the first class interval, it is ending at 20. In the second class interval, it is again starting at 20. Okay, easy. Now, let us learn how to plot the histogram for continuous grouped data. Continuous group data, I have already told you, at the point where the class interval will end, at the same point in the next class interval, it will start, like 5 to 10, 10 to 20. That is your continuous group data. What are the steps? Number 1, convert the data in the exclusive form if it is in the inclusive form. Okay, so your first step is going to be convert the data into exclusive form. Alright, so we will look at an example, don't worry. Second step will be taking suitable scales, mark class intervals on x-axis and frequencies on the y-axis. I've already told you about this. On the x-axis, we are taking the class intervals. On the y-axis, we are taking the frequencies. Third step, construct rectangles with class intervals as the basis and corresponding frequencies as height. So, what is the meaning of all these steps? Let's just look at an example. Consider the frequency distribution table representing the weights of 36 students of a class. So, all the weights are given in kg. So, these are forming your class intervals, right? These are simply acting as your class intervals. Weights in kg. 30.5 to 35.5, number of students 9. That means what? This is your frequency. So, 9 students have weights between 30.5 to 35.5. This is the meaning of this chart. 35.5 to 40.5, 9 students. Again 40.5 to 45.5, 15 students. So on. It is given up to 55.5 to 60.5. Now how to plot this data on the histogram? So on the x-axis, we represent the weights. On the horizontal axis, on a suitable scale, we can choose the scale as 1 centimeter is equal to 5 kg. Okay. So here the weights we will be taking on the x-axis. Alright. And since the first class interval is starting from 30.5 and not 0, we show it on the graph by marking a break on the axis. What is the meaning? And on the y-axis, I have told you we are going to take the frequency. Frequency means what? The number of students. And you have to take the, the plotting in such a way that you see in under frequency, your highest is 15. So you should take the plotting in such a way that we can accommodate up to 15. Because 15 is your maximum frequency. Okay? Now, look at here. Very carefully. So in the chart, you will see that our class interval starts from 30.5, not from 0. So that means we don't have the data from 0 to 30.5. Yeah, because our class interval is starting from 30.5, not from 0. Because we don't have the data from 0 to 30.5, we are going to put this zigzag sign. So this is the break. We are cutting it. Because we don't have the data from 0 to 30.5. But we have the data from 30.5 onwards, right? So here they have taken the plotting as this 30.5, 35.5, 40.5, 45.5, right? So they already told you that you can take 1 centimeter as 5 kg and you can plot it 50.5, 55.5, 60.5, 65.5. Okay, so the difference is just 5 units and we are plotting the weights. That means these are your class intervals. And on the y-axis, we are plotting the number of students. That means the frequency. And the highest frequency was 15. So we should be able to accommodate that. So we can take 2 units. So 0 to 2, 2 to 4, 4 to 6, 6 to 8, 10, 12, 14, 16. Right? So we have done it up to 16. That means we can accommodate up to 15 as well. Now, we now draw rectangles or rectangular bars of width equal to the class size and length according to the frequencies of the corresponding class intervals. For example, the rectangle for the class interval 30.5 to 35.5 will be of the width 1 centimeter and length 4.5 centimeter. Let's see. What is the meaning? Yeah. Just see over here. So for the first class interval, it was from 30.5 to 35.5, right? And what was the frequency of this class interval? Let's see. What was the frequency of the first class interval? It was 9. Now look at the graph. They have taken the frequency as 9 over here. Just see. So 9 must be present between 8 and 10, right? So this 9 is going to form the, what is this? In the rectangle, right? So you can take it as the length also, width also, whatever, in whichever way you want to think of it, right? So here you can take 30 to 30, between 30 to 35.5. What is happening in this rectangle? We are taking the frequency 9 and we are drawing the rectangle, right? Clear? So if you kind of imagine the rectangle in this manner, okay, then you will understand that the width over here is, see, from 30.5 to 35.5, right? That means here it is becoming 5 units, okay? And what is happening about the length? The length is becoming 9 units, right? So this is your length and this is becoming 9 units, okay? This is what they have meant in the previous slide. But you can simply do it as between 30 to 35.5, the frequency is 9 and therefore we are drawing the rectangle like this, okay? Again, in the next class interval 35.5 to 40.5, again the frequency was 9. That's why we have drawn another rectangle like this. Okay, then 40.5 to 45.5, the frequency was, I think, 15, right? It was 15. That's why on the y-axis they have taken up to 15 and 40 to 45.5 they have drawn this rectangle from 45.5 to 50.5. So what was the class, what was the frequency? Let's see, 45.5 to 50.5. The class interval was 3. Okay, 3, then 1, then 2. That's what they have done over here. Yeah, from 45.5 to 50.5, they have taken 3. 3 is between 2 and 4. That's why they have drawn another rectangle. Very easy, right? Between 2 and 4, 3. Okay, and this one is, I think this one was 1. So it was present between 0 to 2. That's why 1. Between 50.5 to 55.5 and between 55.5 to 60.5. What was the class frequency? The class frequency was 2. Okay, so very easy. This is how you can simply draw the histogram. This is very easy. Now, let's look at a case study. Suppose you are a class monitor and teacher gave you a work to analyze the performance of 2 sections of students in a mathematics test of 100 marks. Looking at their performances, you found that few students got under 20 marks and a few got 70 marks or above. So you decided to group them into intervals of varying sizes as follows: 0 to 20, 20 to 30, so on, 60 to 70, and then 70 to 100. Now you have formed the table like this. So here you have the marks. That means the class interval 0 to 20, 20 to 30, 30 to 40, like that. And at last we have 70 to above, means 70 to 100, right? Up to 100 students we had, yeah, 100 marks. Sorry, These are according to the marks, so 100 marks. So 70 and above means 70 to 100 marks. And number of students, these are your frequencies. Okay, and here they have done nothing, they have just added the total number of students and they have written 90. Okay, now you have been asked to draw the histogram for the data. Okay, as you can see from 0 to 20, yeah, 0 to 20, look at how they have divided the graph. They have done it from 0 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Okay, and then we also have 80, 90 and then 100, right? And here, so what was the maximum frequency given in the data? Let's see, maximum frequency 20. Yeah, so we should be able to accommodate 20. That's why they have taken 2 units. So 0 to 2, 2 to 4, like that up to 22 they have done, right? So from 0 to 20, the frequency was 7. Yeah, as you can see on the graph, so 7 is present between 6 and 8. So here you have 7 and here you see it is starting from 0 to 20. That's why no break, because we have the data from 0, starting from 0. That's how they have drawn the rectangle. Again 20 to 30, it is I think 10. Yeah, that's why they have again drawn the rectangle. 10, 10, 20. Yeah, exactly. Okay, so they have simply followed the chart and they have drawn it. Okay, so 20 to 30, between 20 to 30 frequency is 10. That's why the rectangle is forming in this way. Between 30 to 40 the frequency is 10. That's why the rectangle is forming in this way, right? And 40 to 50, 20, like that they have continued. And for 70 to 100, what was the frequency for the last one? 70 to 100, the frequency is 8. Yeah, so they have drawn the rectangle up to 8 from 70 to 100. Okay, now what will happen, you know, there is some problem with this. This is not correct representation. Why? Because here the rectangles are of, different widths. The widths of all the rectangles are varying over here. But previously the widths of all the rectangles were equal, right? So previously we were taking it as, 0 to 10, 10 to 20, 20 to 30, like that. But here in the rectangles you can see this one is from 0 to 20 and then again 20 to 30, 30 to 40. Okay, so here your width is of 20 units and last one you can see it is from 70 to 100, right? So the width is not uniform in all the rectangles. Therefore, this is a problem. And we cannot represent the data in this manner whenever you have varying widths of rectangles. From the histogram, it looks like a greater frequency in the interval 70 to 100 than in 60 to 70, which is not the case, right? So 60 to 70 frequency is 15, 70 to 100 frequency is 8. But if you look at the histogram, it is appearing as if from 70 to 100 the frequency is much greater. But that is not the case, right? So how can we solve this problem? Firstly, you have to select a class interval with minimum class size. In the example, the minimum class size is 10, right? Let's look at the class sizes. 0 to 20, 20 units. 20 to 30, 10 units, right? So 10 will be your minimum class size. 30 to 40, 10 units, like that. And 70 to 100, difference will be 30 units. So definitely we can't take it as the minimum. It is the maximum. So minimum will be 20 to 30, 10. 10 will be your minimum class size. The lengths of the rectangles are then modified to be proportionate to the class size 10. So the length of the rectangle will be, okay, let's look at the chart directly, then you will understand it better. Alright, just see what is happening over here. What they are doing is, they are taking the width. So here width is from 0 to 20. That means what? 20 is the width. And they are modifying the length of the rectangle. How? They are simply taking the frequency 7 divided by 20, whatever is the class width, okay? And then they are multiplying it with the 10. 10 was our minimum class size, right? They are multiplying it with that. And we are getting 3.5. So this part is called as your frequency density. Frequency density, which is nothing but whatever is the frequency divided by class width. Okay, this is the frequency density multiplied by the minimum class size, which is 10, and we are getting it as 3.5. For this one also, the width is 30 minus 20, 10, frequency is 10. So 10 divided by 10, frequency divided by class width multiplied by minimum class size, which is 10. We are getting the answer as 10. This one also the same. Here number of students, that means frequency 20 divided by the class width, which is 10, multiplied by the minimum class size, which is 10, and we are getting it as 20. This one also similarly, 20 divided by 10 multiplied by 10, 20. 15 divided by 10 multiplied by 10, which is equal to 15. 8 divided by, here it will be 30, right? Because 8 is the frequency and the class width is 30. So 8 divided by 30 multiplied by 10, and we are getting it as 2.67. So why we did it? Because our rectangles were of varying widths and we want to form, a proportional thing. We want to make it proportionate to the minimum class size, which is 10. All right. Now this is your correct form of representation. Now you can easily do it. Right. Now you can easily see marks on the x-axis. On the y-axis you can see proposition of students per 10 marks interval, right? So we took the minimum class size as 10 and that's how the graph has been plotted. So now from 0 to 20 we can take the frequency as 3.5. See, 3.5, that is between 2 and 4. 3.5, this is your rectangle. Then again the next one will be 10, 10, 20. Yeah, that's how they have done it. And for the last one, now see, last one 70 to above, that means 70 to 100, you can see 2.67. 2.67. Yeah, see, that is present in between 2 and 4, 2.67, and this is how they have plotted it between 70 to 100. Now this is fine. Okay, now we have formed a proportionate histogram, right? And that is proportionate to the minimum class size. Understood? This is how you will have to solve it. Whenever your widths are of varying lengths, you have to choose the minimum class size. Then you have to take each and every take the frequency, divide it. We are finding the frequency density, that is we are taking the frequency and then we are dividing it by the class width and then we are multiplying it with the minimum class size, right? And that's how we are getting the answer. Just revise it once again, right? So we are taking the frequency, number of students 7, divided by what? The class width, which is 20. How did we get 20? Because 20 minus 0, 20 multiplied by the minimum class size. Minimum class size is 10. And this is how you need to follow and then consider this as your frequency and then simply form the histogram. Easy. How will you plot the histogram for the discontinuous grouped data? So now you don't have continuous data, you have discontinuous data. So how are you going to plot the histogram? See, the length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is represented in the following table. So why is it discontinuous? 118 to 126, 127 to 135. So what is happening? Ending at 126, starting at 127, ending at 135, starting at 136. So this is your discontinuous, right? So now you have to make the class intervals continuous, then only we can plot the histogram. How to make it continuous? Very simple. Okay, just look at this 126 and 127. What is the difference? 127 minus 126, we will get a 1. Okay, difference is 1. Simply divide it by 2 and we will get 0.5. Okay, we are getting it at 0.5. See here also 136 minus 135, 1. Dividing it by 2, we are getting 0.5. 145 minus 144, 1. Dividing it by 2, we are getting 0.5. Okay, it's the same for all the cases. Now what you will do, take this 0.5 and from the lower limit simply subtract this, and from the upper limit, that is from the 126, simply add this 0.5. Okay, then what will happen? Here you will get 118 minus 0.5, that means 117.5 to 126 plus 0.5, that means 126.5. all right, this is how you can form the class intervals, and now this will become your continuous. How? For the next one, see, 127 minus 0.5, that means the next one will be again 126.5 to 135.5, right? And the next one will again start from 136 minus 0.5, that means 135.5 to 144.5. So now it is becoming continuous, right? Can you understand this? Let me just show it to you once again. What we are doing over here, we got 0.5 how? 127 minus 126.1 divided by 2.5, subtracting 0.5 from the lower limit, adding 0.5 in the upper limit. So that's how we are getting the answer as 117.5 to 126.5. Next one will be 127 minus 0.5, that means 126.5 to 135.5. 136 minus 0.5, so 135.5 to 144.5. Can you see? Now it has become continuous, ending at 126.5, starting at 126.5. Now it is continuous, and now you can easily plot your data. See, so easy. 117.5 to 126.5, then they have plotted the frequency and we have got the rectangle. Why is there a break? Because we don't have the data till 117.5, right? From 0 to 117.5, we don't know what is happening with the data. That's why we have applied a break, and we are starting from 117, 126.5, and then again 126.5 to 135.5, 135.5 to 144.5. Simply they have taken the frequencies and they have plotted the histogram. Very, very easy. So whenever you will have a discontinuous group data, firstly convert it into continuous group data and then plot your histogram. How will you plot the histogram when class marks are given? Okay, so now what has happened? Only the class marks are given, like 25, 35, 45, 55, 65, like that. Okay, and the frequencies are given. So now what will happen? You have to convert the class marks to your class intervals. How will you do that? Very easy. Simply take this 35, take this 25. So 35 minus 25 is equal to 10, and simply divide this 10 by 2, then you will get 5. Now with this 5, for the first class interval, we will simply do 25 minus 5 will be your lower limit, that means 22. For the upper limit, you will do 25 plus 5, that is 30. So you are getting from 20 to you are getting up to 30. Understood? Very, very simple. For the second one also, 35, 45 difference is 10. 10 divided by 2 is 5. So for the second class interval, it will be 35 minus 5, that is 30. What will happen to this 35 for the upper class limit plus 5 again? So 240. Now see, this is your continuous data as well, right? Ending at the same point, starting at the same point. Understood? Very, very easy. Yeah, this is exactly what is mentioned over here. And see, 20 to 30 frequency 7, 30 to 40 frequency 15, 40 to 50. How did we get 40 to 50? Let me show it to you once again. So what is happening? 55 minus 45, 10. 10 divided by 2 is 5. So we will do 45 minus 5, that is 40. This will be your lower limit. 2 45 plus 5, that is 50, and this is going to form your upper limit. Very easy, right? Very, very easy. Okay, and the frequencies are given. Now you know what to do. From 0 to 20, we don't know the data, that's why you have a break. 20 to 30 frequency is 7. That's how they have drawn the rectangle, right? 20 to 30 frequency is 7, between 6 to 9, and here they have drawn the rectangle accordingly. Okay, now you know what to do. Then from 30 to 40, what is the frequency? 15. Yeah, so they have taken the frequency 15 and drawn the rectangle, right? Very easy. So let's do a small recall now.
In this video, we're going to look at a way of presenting data, the histogram. There are lots of misconceptions about histograms, and we will try and clear up some of these along the way. Consider this frequency table of data. You might be tempted to plot the information in a bar chart. However, if you did, it would end up looking like this. At first glance, this might look perfectly fine, but there are actually a couple of issues with it. Firstly, the data in our table is continuous, meaning that there is a group for every value. including non-integers within the range of 100 and 200. Bar charts are not used for continuous data because they require gaps between the bars, and gaps don't work for continuous values. The second problem is that the group 150 to 160 has the same height as 120 to 140, even though it represents a smaller range. This therefore does not give us a true comparison of the data. To solve these issues, we use something called frequency density. Because plotting against frequency doesn't work when the group sizes, also known as class widths, are different, we plot against the frequency density instead. We calculate frequency density by dividing the frequency of each group by the size of the group. As density is a measure of how much mass there is in a volume, frequency density is a measure of frequency in a set space. This allows us to solve the problem with unfair comparisons, as all values plotted will have their group size accounted for. We start by adding an additional column titled frequency density. We then divide each frequency value by its corresponding class width to find the frequency density. Pause the video and see if you can work out the frequency density for these values. Let's see how you did. The first frequency value is 20, which divided by a class width of 20 gives us a frequency density of 1. The remaining values are found like this. We can take these values and plot them against frequency density, not frequency. If you want to try this yourself, pause now. The completed histogram should look like this. The bars touch on a histogram, which works with our continuous data, and we can draw clear conclusions about what the data shows now. As we can see, now the group 150 to 160 is taller than the 120 to 140, showing a higher frequency for the same class width. It's also important to be able to interpret the data in a given histogram. Take a look at this one here. Estimate the number of people who took between 30 and 90 seconds to complete the test. If you want to have a go first, pause the video now. Firstly, we need to rearrange our histogram equation to find frequency. Because frequency density is equal to the frequency divided by the class width, to find frequency alone, we have to multiply the class width by the frequency density. If we look at our histogram, we plot frequency density against class width, so the area of each bar is the same as its frequency. Rectangle 1 has a height of 0.5 and a width of 30, because the bar's width is 30 seconds to 60 seconds. Multiplying these tells us there are 15 people in rectangle 1 between 30 and 60 seconds. Rectangle 2 has a height of 1.5 and also a width of 30 seconds, from 60 seconds to 90 seconds. 1.5 multiplied by 30 equals 45 people, so in total there are 15 plus 45, giving an estimate of 60 people. Have a go at this question. Estimate the number of people whose average speed was 10 to 40 miles per hour. Rectangle 1 has a width of 10 between 10 seconds and 20 seconds. A frequency density of 2, so 20 people in total. Rectangle 2 has a width of 20, from 20 to 40, and a frequency density of 6, so 120 people in total. There are therefore, as an estimate, 140 people whose average speed was in the range of 10 to 40 miles per hour. It's important to remember that when you have different class widths, you need to plot frequency density on the y-axis. You can, however, have a histogram with frequency, but the class widths must be even. These tend to feature discrete data such as shoe sizes and scores rather than continuous values.
If you
Yes.
liked the video, give it a
So that was a quick recall, right? Okay. Let's look at some questions now. Yeah. Draw the histogram for the following. So the class marks are given to you and the frequencies are given to you, and you have to draw the histogram. So let's see how to do it. So the class marks are given as, let me just quickly recall. Here you have the class marks and here you have the frequency. So class marks are given as 15, 25, 35, 45, 55. And the frequencies are given as 9, 15, 18, 12 and 6. Right? I told you how can you find out the class intervals? Very easy, right? So difference between 25 and 15 quickly. 25 minus 15, 10. 10 divided by 2 is 5. So from this 15, subtract 5 once. So 15 minus 5, 10. 2, 15 plus 5 for the upper limit. 15 plus 5, that is going to give you 20. Similarly, again, 35 minus 25 is 10. 10 divided by 2 is 5. So here also you have to do 25 minus 5 for your lower limit. So it is going to give you 20. 2, 25 plus 5, that is going to give you 30. Okay. Similarly, 35 minus 5, that is going to give you 30. 35 plus 5, that is going to give you 40. Okay. This is how you can do it. 40 to 50, and last we will have from 50 to 60. And the frequencies that we have. Frequencies 9, 15, 18, 12 and 6. Now you know what to do. Now it is very easy. Okay. So we will take the y-axis and here we will take the x-axis. On the y-axis we will plot the frequency. On the x-axis we will plot the class intervals. Right. So class intervals are from 0 to 10. 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, right? And for the frequencies, what you can do, we can take it as, so we have to accommodate up to 18. So 3, then 6, then it can be 9, then it will be 12, and then 15, and then 18. Okay, from 0 to 10 we don't have the data, so break it. And from 10 to 20 frequency is 9, that means here. So your first rectangle will be here. 10 to 20, 20 to 30, 15. Here you have 15 frequency. This will be your second rectangle, right? Then from 30 to 40 frequencies is 18. Here you have 18. This will be your third rectangle. 40 to 50 frequency is 12. Here you have 12. 40 to 50, this will be your fourth rectangle. And then 50 to 60, 6. Here you have 6. This will be your last rectangle. Okay. Make sure to do it with a scale. Now I am doing it with my bare hands, but you will have to do it with your scale. Okay. Your graph needs to be really neat and clean. All right. Let's see what is next. Okay. Did you know there is a fun fact for you? Google statistics, according to the data collected, Google processes 100 billion searches a month. Oh my God, can you imagine? In one single month, Google processes 100 billion searches. Okay, so let's see what we have learned today. We learned about the definition of histogram. We learned how to plot the histogram for continuous group data. We learned how to plot the histogram for discontinuous group data, and we also learned how to plot the histogram when class marks are given. Okay, now here we have some extra time questions. Let's see what to do with. Let's try to solve these. Okay, try to solve it with me. So 30 to 39, 40 to 49. Here what is the problem? The problem is discontinuous data. 39, 40, right? So ending at 39, starting at 40. That means discontinuous group data. So you will have to convert it into continuous group data. How you can do it? Take this 40, take this 39. So 40 minus 39 equals to 1. 1 divided by 2 equals to 0.5. Then I told you from the lower limit, simply you need to subtract 0.5. So 30 minus 0.5, that is going to give you 29.5. And from the upper limit, 39 plus 0.5, that is going to give you 39.5. And this is how you will get your continuous data. Okay, let's see. Let's try to solve it. Let's see how it is going to give us our continuous data. Okay, so your class in the given question, you have 30 to 39 class intervals, and frequencies are given to you as 25, 15, 10, 30 and 20, and the class intervals are 40 to 49 and then 50 to 59, 60 to 69 and then 70 to 79. Okay, how to convert it into class intervals? So from the lower limit, minus 0.5, 30 minus 0.5, 29.5 to 39 plus 0.5, 39.5. Then we will have 39.5 to we will have 49.5. Then 50 minus 0.5. So it will be 49.5 to 59.5. Can you see we are having continuous data now? 39.5 ending at 39.5, next class interval starting at 39.5, right? So we are having continuous data over here. Okay, now what to do? You know the frequencies are given to you, everything is given to you. You simply need to plot. Very easy. This will be your y-axis, this will be your x-axis. On the y-axis we will plot the frequencies, and the frequencies are given as 25, 15, 10, 30, 20. So you can simply take it as 10, and then next one 20, and then 30, then 40, 50, like that. And on the x-axis you can take it as 29.5, right? It was starting from 29.5, then it was 39.5, then 49.5, and then it will be 59.5, and then it will be 69.5, and then it will be 79.5, right? And we don't have the data for this, that is from 0 to 29.5. So apply a break, and now you know what to do. From 29.5 to 39.5, the frequency is 25, that will be present between 20 and 30. That means here. Okay, and make sure to draw the lines really neatly like this. You will have to draw the rectangle. We'll proceed up to 39.5 like this. From 39.5 to 49.5, frequency is 15, which will be between 10 and 20. So this will be between 10 and 20. Okay, yes. 49.5 to 59.5, frequency is 10. Here you have your 10. So this will be your rectangle. Just see, so easy. 59.5 to 69.5, frequency is 30. Here you have your 30. So draw the line like this. Straight line. Straight line 30. Yeah. Yes. Right? And then 69.5 to 79.5, we have 20. Here you have 20, and this rectangle will be continued up to 20. Understood? So easy, right? Very easy. Okay, great. Let's see what we have next. Okay, here we have continuous data type only. 0 to 10, 10 to 20, the frequencies are given. This is the easiest one possible. Continuous data type is given to you. I want you to solve this problem on your own as your homework, okay? And then on the comment section, you should write whether you have done it or not, right? This is very easy. You know what to do. On the y-axis, you will take the frequencies 10, 20, 30, like that. Alright, you can also go for 5 units like 10, then 15, then 20. Okay, then it will be easier for you to express 14. It will be easier for you to express 16. Okay, so you can also take 5 units gap. So 10, 15, 20, 25, like that. You can take like that. And class intervals, so very simple. 0 to 10, 10 to 20, so no break also. Very easy. I want you to do it on your own and write it down in the comment section whether you are able to do it or not. Okay, thank you so much for attending this session. I hope you enjoyed the session. If you have any doubt, make sure to write it in the comment section, as well as I've given you some work to do, right? So do it, plot your histogram, and then let me know in the comment section as well whether you were able to plot it precisely or not. All right, thank you so much. If you like the session, make sure to hit the like button, as it is going to motivate us to teach you various things right, and bring to you knowledgeable videos. Subscribe to this channel and also hit the bell icon so that you never miss any video update from us. Okay, thank you. Tata, bye bye, take care, and make sure to do your revision.